Hello, students. I'd like to take this opportunity to talk about the unit circle a little bit more fully. Section 13.2 in your Algebra 2 textbook starts to touch on this topic, and I'd like to kind of fill in a lot more on this for you. What is the unit circle? Well, the unit circle is a circle with a radius of 1, and it's a tool that's used to help figure out the various trig functions, and it can figure out all 6 as a matter of fact, using this tool. And it's kind of an easy way for students to remember this tool. And you know and work through these various trigonometric equations and so forth without having to use your calculator. And of course, nowadays you have your calculator, and that's all fine and good, but it did come from something, and I kind of want to show you where it came from and how to use it. I think it's important for part of your mathematical cultural education. All right, so where does the unit circle come from? Well, first of all, what it's really looking at is it's looking at the trig functions of special triangles. And then what are the special triangles? Well, the special triangles, if you remember from geometry, were the 45 degree, 90, right, triangles, and the 30, 60, 90 degree triangles. All right, so 45 triangles. What was up with that? Well, let's remember. Let's kind of go down memory lane a little bit. That's an isosceles right triangle, correct? And that means that these are 45 degrees and 45 degrees, right? And these legs are equivalent. Now remember the relationship between the legs of a 45 degree triangle and the hypotenuse. Well, if this leg is equal to a unit of 1 and that's equal to 1, well, what is this equal to? Well, it is equal to 1 squared, right? Using the Pythagorean theorem, plus 1 squared equals, we'll call that hypotenuse squared, right? So that's 2 equals hypotenuse squared. So hypotenuse is going to equal what? The square root of 2, right? So this is equal to the square root of 2. So if I wanted to, for example, to find the sine, right, of 45 degrees, what would it equal? Well, it would be hypotenuse, right? SOHCAHTOA, sine is equal to the opposite. So it doesn't matter; these are both the same, right? Since they're equal. Opposite, the length of the opposite side divided by the hypotenuse, right? So that's equal to 1 over the square root of 2. And of course, if we rationalize the denominator, it's going to equal 1. It's going to equal square root of 2, right, over 2. And cosine of 45 degrees turns out to be the same thing, right? Equals the square root of 2 over 2. All right, so you're going to see how this fits in soon with the unit circle. But I just wanted to kind of remind you about this. All right, now if we have a 30, 60, 90 triangle, now where does that come from? Well, it starts off with like an equilateral triangle to start with, right? All the sides are equal, and if all the sides are equal, that means all the angles are equal, right? 60, 60, 60 degrees. And if I wanted to drop an altitude from here down to the other side, all of a sudden now I'm looking at a 90, 30, 60, 90 triangle on this side, right? Just to make my math easier, I'm going to call this everything equal to 2, all right? So that means that this is half of 2, right? So that's 1. And if we calculate the long leg here, what that is, we'll call that x for right now. We know that x squared plus 1 squared, it's a short leg, is going to equal my hypotenuse squared, right? So x squared plus 1 equals 4, so x squared is going to equal 3. And then, so if I take the square root of each side, what does x equal? X is going to equal the square root of 3. All right, so here it is. So that means like if in a 30, 60, 90 triangle, here, let me erase this a little bit. So that means in a 30, 60, 90 triangle, I know that if my hypotenuse is 2, I know that my short leg is half of that, right, which is 1. And I know that my long leg is the square root of 3 times the short leg. Yeah, do you remember that from geometry? 30, 60, 90. So if I did, let's say I said I wanted to know what the sine of 30 degrees is. What is that? Well, that's the length of the opposite side divided by the hypotenuse, so that's going to be 1 over 2, so equals 1/2, right? Cosine of 30 degrees, well, that's adjacent, right? So that's square root of 3 over the hypotenuse, which is, 3 over 2. All right, so you remember that about the special triangles. Okay, so now what we're going to do is we're going to apply that to something we call the unit circle. And then also I just want to just kind of briefly touch base too about radians. Radians are just another measure of angle, except it's based on the radius. So if I have a unit circle, that means my radius is equal to 1. Okay, first of all, and if I'm measuring a circle in radians, I'm measuring the number of radii that would go around the circumference. So if I were able to pick up that radius and plunk it around the circle, how many times do I go around the circle? Well, remember what the circumference of a circle is. It's right, 2 pi r, right? And if I have a unit circle, that means my circumference is equal to 2 pi times 1, all right? So that means all the way around the circle, I have 2 pi radians in a unit circle. So 2 pi radians. And we kind of use that to show, and you know, keep in mind your calculator will measure circles in radians as well as in degrees. So make sure that if you're working with radians, make sure you have the right mode on. But 2 pi radians in a unit circle, right? What is that equal to? Well, 2 pi is going to equal 360 degrees. Okay. So if you ever want to do a conversion factor, you're going to say there's 2 pi radians and 360 degrees, okay? Or if you're going to be converting the other way around, you're going to say 360 degrees and 2 pi radians. Of course, when we simplify this out, we end up with pi over 180, or we're going to end up with 180 over pi. And so you kind of use these as your conversion factors when you're converting back and forth between degrees and radians, depending on what you want to, depending on how you want to put your answer down in terms of this. All right, so this is the unit circle. And ideally, I would like you to memorize it, although you don't really have to memorize it because it kind of makes sense and it holds together. And so this is the tool that you can use then to figure out what the sine and cosine is of every angle that's out there. All right, now the way that we start off with this is we're going to start off by putting in the degrees going all the way around, okay? And just so you know, right, the standard degree it starts this way. This is like the standard measurement of an angle, and it goes counterclockwise. It goes in this direction. All right, so if I were to just start right here, I mean, I know that right here, from here, this is 0 degrees, right? And then if I open up my angle all the way over to here, how far have I gone? I've gone 90 degrees, correct? And then if I go all the way this way, I've got a straight angle going on now between here and here, this and this, right? So how far have I gone around now? Well, that's 180 degrees. And then if I keep going, I'm going down here, right? That's 270 degrees. I've gone another 90 degrees, in other words. And then I come back around, and what is this again? Well, that's going to be 0 and 360 degrees, right? Are in the same place. All right, so let's just fill in a few more of these numbers. Okay, so let's say we're going to go, well, they're doing this one in thirds, aren't they? Okay, because I also have one that's like, half. And yes, I've got a different one too that's going to add a bit more in here. Let's do the thirds first. So this is 0. I'm going to add 30 degrees. It looks like I'm doing thirds. So that's 30, right? And then I'm going to add 30 more degrees. That gives me my 60, right? Add 30. There's my 90 again. Add 30. So that's got to be 120. Add 30. That's 150 degrees. And then now I'm back at 180. Okay, add another 30. That's 210 degrees. Add another 30. 240. Another 30. There's 300. And then I get 330 right here. I've got a blank unit circle that I'm going to want you guys to fill out that also has the halfway part between each one. And I'm trying to make sure I've got that right. Kind of here and here. Okay, so this would be 45 degrees. And then that's 90. This is going to be 135 degrees, another 45 degrees from 90. And then it's going to be over here, another 45 degrees here. So that's going to be 225 degrees. And then 270 plus 45. I think that's going to give me a 315 degrees. Okay. All right, so now I've got all the degrees in here. Now let's put in the radians, okay? So the equivalents of the various radians. All right, so I think the easiest way to think about this is how many radians do you have going all the way around the circle, right? If your unit, and each of these radii, right, are equal to 1, well, that means you got 2 pi r, 2 pi times 1, so that's 2 pi. So it's 2 pi all the way around. So if I go just halfway around, how many radians have I gone? Well, I've gone pi radians, right? If I've gone halfway around the circle. If I go all the way around, right, it's going to be, well, it starts off as 0 radians, but then, 0 radians, and then it ends up being 2 pi radians. Okay, 0 and 2 pi are going to be laying on the same place. All right, so now if I know that I've gone pi here, if I've gone halfway between 0 and pi, then at the 90-degree mark, what is that? Well, that's pi over 2 radians, right? That's half of pi. All right, so that means that each 90 degrees is the same thing as pi over 2. So if I've got pi over 2 here, from here to here, and then I got another pi over 2 from here to here, then that's basically saying 2 pi over 2. And then I'm going to add another pi over 2 over here. Then what do I have? I got 3 pi over 2, right? And then I'm going to add another pi over 2 to that, and that's going to give me 4 pi over 2, which is the same thing as 2 pi, okay? All right, so that gives me all the kind of the quarter marks there. So let's look at this in terms of if I go all the way around here, these are like, I mean, how many chunks do I have here of this circle? If I look at the black marks that are already in here, right? If I count all the way around, I got 1, 2, 3, right? They're doing it every 30 degrees, right? So if I'm going to do 360 degrees, how many of these pieces do I have going all the way around? Well, I've got basically, they're each 30 degrees, but I've got 12 of these pieces going all the way around. And I got 12, divided by, that's going to be going into 2 pi, essentially, right? So each of these things is really worth pi over 6, okay? So this first thing right here is pi over 6. Okay, 30 degrees is the same thing as pi over 6, right? All right, so I'm going to add, every time I add 30 degrees, I'm adding a pi over 6, and I'm going to kind of also simplify the fraction for this. So if I'm going from 30 degrees over to 60 degrees, I'm basically going from pi over 6 to another pi over 6. So that's 2 pi over 6, right? And 2 over 6 is the same thing as 1/3. So this becomes pi over 3, okay? And then I add another pi over 6 on here. And I'm basically going to get 3 pi over 6, which is the same thing as pi over 2. All right, now I'm going from pi over 2 here. I'm going to add that, which is really, what is that? That's 3 pi over 6. I'm going to add another pi over 6 here. That's 4 pi over 6. And that's going to be the same thing then as 3 pi, 2 pi over 3. All right, adding another. So this is really 4 pi over 6. Next thing, 5 pi over 6, right? 6 pi over 6 is the same thing as just pi, right? Next thing, 7 pi over 6. Then this one right here is going to be 8 pi over 6, and we're going to reduce that fraction, right? So 8 pi over 6 then is going to be the same thing. I'm sorry. This is 6 pi over 6. 7 pi over 6, right? 8 pi over 6. Okay, which is going to be 4 pi over 3. Yeah, divide by 2, divide by 2. All right, and then I come back over here. That's still 3 pi over 2. So, okay, so this is, we said this was 8 pi over 6. 9 pi over 6 is this. This is 10 pi over 6 right here. So that reduces to 5 pi over 6. And then over here, this is, okay, so we said 10 pi over, what is this? Oh, I'm getting this wrong. 3. Okay, yeah, I'm getting myself confused here. 7 pi over 6, 8 pi over 6, 9 pi over 6. 10 pi over 6. Okay, I don't know. I'm going to have to look at this again. 5 pi over 3. Okay, 7. Okay, then I'm going to, okay, right here is 11 pi. Ew, this is bad. I'm sorry. 11 pi over 6. 12 pi over 6. Okay, so that's 11 pi over 6. 10 pi over 6, right, which is the same thing as 5 pi over 3. Got that. All right, and then coming through here. Yeah. Okay, so I think I got this right. I'm going to give you a cleaner version of this by the time we're done. All right, now in terms of the 45-degree angles, and I don't have any blanks in here for those, but think of it this way. If I know that halfway around is pi, I know that pi over 2 is a quarter of the way around. So half of a quarter, right? So half of pi over 2 is going to give you pi over 4. Okay, so this is pi, so every 45 degrees you're going pi over 4. So this is pi over 4, and then you go another 45 degrees, that's where you're at 90. That becomes 2 pi over 4, which is pi over 2. So 2 pi over 4, then this becomes, this one right here is going to become 3 pi over 4. And then coming through here, that's going to be 4 pi over 4, which is the same thing as pi. This is going to be 5 pi over 4. And then this becomes 6 pi over 4, which is the same thing as 3 pi over 2. And then over here, this is going to be 7. This is going to be 7 pi over 4 radians. And then, of course, we come back around here, and now you're at 8 pi over 4, which is, again, 2 pi. All right, so now we've got all the radian measures and everything like that in there. And, of course, this is like so busy now you can barely see what's going on. All right, so what I want to do now is why this is useful is for the next reason, actually. It's these coordinates. What we're going to do is we're going to fill in what these coordinates are, and essentially what is going to happen is you're going to find out that the x value is actually the cosine of an angle, and the y value is the sine of the angle, okay? And I'm using theta here to represent the angle, the Greek letter theta. Well, why is that? Well, because each of the unit circle, the way that it's written, each of these things are angle measures, and they form these triangles. And what you're going to find out is that that the angle that it's forming, as an example here, is going to be the x value right here is going to be equal to the cosine, and then the y value of it is also going to be equal to the sine, because the hypotenuse is always going to be equal to 1, because that's the radius. So if this is a 30-degree angle, for example, and I want to know what the cosine is, Well, that means that this side, right, is going to be the cosine of 30 degrees is going to equal my adjacent side, which is my x value, over 1, right? So this ends up being the cosine of 30 degrees. Well, what is the cosine of 30 degrees? Well, it ends up being, remember, we figured that out kind of over here. What was the cosine of 30 degrees? It ended up being the square root of 3 over 2, right? And so this is how this is going to kind of work out. You're going to figure kind of all of these things out for these different positions. The sine of 30 degrees, what's that going to be? Well, that's going to be the y value over 1, and it turns out that that y value is the sine of 30 degrees, and that's going to equal 1/2. Okay, so let's just kind of go around a little bit on each of these and try to, we'll figure out some of the easier ones, and then we're going to go and do some of the more, but you're going to find out there's a pattern to the whole thing, okay? All right. So let's start here with this right here, cosine of 0 degrees. Well, basically they're just saying what is the, what is the x value of this position right here? And that's basically at a 0 angle, right? So what is the x value here? Well, it turns out to be 1, right? Well, that ends up being the cosine of 0 degrees. If you put cosine of 0 degrees in your calculator, it will tell you that that is equal to 1. Now, what's your y value right here? Well, you're sitting at 0, right? Your y, you're not anywhere on the y-axis, so that ends up being 0. So if you did sine of 0 degrees, in your calculator, it should return 0. And you can also turn the whole thing into radians too, and go in radian mode and say 0 radians. It'll say cosine of 0 radians. It'll tell you 1. Cosine of 0 radians. Sine of 0 radians, and that'll give you equal to 0. So it turns out that this is cosine of those angles, the 0 angles. Okay, now let's look at the 30-degree angle. Okay, now the 30-degree angle, remember, is we have a here. This is the 30 degrees right here. Okay, this is my 90 degrees, right? This is my 60 degrees. So where's my short side? This is the short side, right? And this is my long side right here. And so remember the relationships that we had there of these various sides, right? Of course, here I'm looking at a radius of 2, which is that, and now my radius is 1. But it turns out that if you use 1 as your hypotenuse now, and you know that your short side, right, is half of the long side. And remember, the long side is the square root of 3 times the short side. So this means that's the square root of 3 over 2. So that means your x value here at the 30 degrees is equal to, so this, the 30 degrees, now the cosine is going to be your long side. So, and x is the cosine, right? Because it's going to be the adjacent square root of 3 over the hypotenuse 1. So this ends up being square root of 3 over 2. And then the sine is going to be what? Opposite, remember SOHCAHTOA, half over the hypotenuse. So this ends up equaling a half. Okay? Now, when we go over here to the 60-degree angle, it's kind of, and let me clean this up just a wee bit. It's sort of, the relationships are kind of opposite, but they're similar again, except now my long side is the y value right here, and my short side is this, is the x value. Okay, so remember cosine is the same thing as x. So my cosine here of 60 degrees, it's going to be the adjacent over the hypotenuse, which is equal to 1, right? Because it's a unit circle. And so we said that if this is 1, then this has got to be, the short side's half of the hypotenuse, right? And the long side's the square root of 3 over 2. So it's the square root of 3 times the short side. And so that means that my cosine of 60 degrees is equal to a half. And my sine is going to be the square root of 3 over 2. Okay, so what you're going to find out then is on all these 30, 60, 90 triangles, you're going to have some combination of the short side being a half and the long side being square root of 3 over 2. And you're making that decision in all these different quadrants of what those coordinates are. So like, let's say we go right over here. Let me clean this up just a wee bit. Let's go over to right here, where we have 120 degrees, okay? And we want to know what the cosine, of that is and the sine is. Okay, well, so you're looking at this same triangle again, okay? Now you're looking at this and you're trying to make a decision. Okay, where is the short side now? Well, the short side looks like it's the x, right? And the long side is the y value. But you're in quadrant 2. So what is the cosine of this going to be? Well, it's now going to be the short side, but the x is negative in this quadrant, so it's negative 1/2. That's my short side. And the long side is still positive, square root of 3 over 2, right? And so you're going to keep doing this. It's for every 30, 60, 90 triangle. That's exactly what it's going to be. It's either going to be 1/2 square root of 3 over 2, and you have to just decide which position is which. So like if I go over here, let's say to 225 degrees, I'm going to look at that, and it's going to be, okay, here's my angle now. It's 30 degrees. Okay, so it's 30 degrees this way, right? What's the short side? Well, the short side's y now. It looks like the long side is x, and they're both negative, right? So if the long side is x, that means it's negative square root of 3 over 2, and the y value is going to be negative 1/2. All right, and then, I keep going over here. Let's say I'm going down here to 300 degrees now. It looks like, okay, my angle, okay, is going to be, I'm really looking at kind of like that 60-degree angle. So what's it going to be? It looks like the long side is going to be y. It's going to be negative, but my x is going to be positive. So I'm going to make this 1/2, and then my y is going to be negative square root of 3 over 2. And did I fill all of those in? Okay, that's the hardest part of this, is just the 30, 60, 90 triangles and how this all fits. But basically, you're toggling between 1/2 and the square root of 3 over 2. Long side gets the square root of 3 over 2. Short side gets the 1/2. And then you just have to make adjustments for whatever quadrant you're in terms of the x and the y value, whether that's positive or negative. All right, now the easiest ones actually are these pi over 4s, the halfway, the 45-degree angles, okay? That is always going to be the square root of 2 over 2, okay? Because remember, if your hypotenuse in this case is 1, right, then each of the legs are going to be equivalent, and they turn out to be the square root of 2 over 2. And so every one of these pi over 4s of 45-degree angles, the coordinates are always going to be square root of 2 over 2. They're equivalent in length. Okay, because you're talking about the the isosceles right triangles there, and then you're just simply adjusting for you're simply adjusting for the quadrant again. So like if I did let's say this is 4590, and then I go over here and I kind of erase this, okay, and then this ends up being the 135 degree, which is going to be, this was what? This was 0. This is pi over 4, 2 pi over 4. This is 3 pi over 4, and I erased this. Okay, then it's over here in the second quadrant, right? The x and the y's are equivalent. They're both square root of 2 over the square root of 2, except in the second quadrant here, I know that my x value is negative. So if you were to do the cosine of 135 degrees in your calculator, it will be equivalent to the negative square root of 2 over 2. And if you did it in radians, you'd have to punch in 3 times pi, in radian mode, you'd have to say cosine 3 times pi divided by 4, and you would end up with the same thing. The cosine is negative square root of 2 over 2. And, ditto if you did the sine, okay, of that. All right, so you are, if you go down here and you fill this out, you're going to have, all these are going to be variations of square root of 2 over 2. Every single, 45-degree angle going, well, each of the halfway points here. All right, now, and then I didn't fill this in, did I? Okay, the coordinate here, if I look at this coordinate, right, I'm sitting at -1, 0. And down here, what's this? This is going to be, and I don't see a place to put it, but this is going to be 0, -1, right? And then over here, we are at 1, 0. And then up here, we are at 0, -1. So that's the sine of 90 degrees. In other words, is 0. I mean, the cosine of 90 degrees is 0, and the sine is, oh, this should be +1. I'm sorry, +1. Okay, and that would be +1. The sine of 90 degrees would be positive. All right, so I'm going to give you guys a blank one of these, and I want you to fill it in and then kind of remember it. And I'll give you another video that shows how to remember this easily. Now, why is this useful? Because I can find the sine and cosine of any trig function in here by using this unit circle. And I can find it if the angle is given to me in radians as well as degrees. And if I can find any of these, since, for example, tangent is equal to sine over cosine, then I can find the tangent of any of these angles. And then I can find all the reciprocals, which means I can find the secant and the cosecant and the cotangent just using this unit circle. So it's kind of a useful thing, and I find that I still remember how to use this even now in my old age, and I can basically logically reason through how it's set up, and then use that to help me figure out these various trig ratios more easily. All right, so I know this is messy and this may be confusing at first, but I think once you start filling one of these in, it'll come together, and then you'll understand how to use it. All right, that's it for now.